Hello there, it's Jay here from Jay's Vintage Junk, and this is going to be part 4 of the little One Valve Wonder Treasure series. Now I've been having a bit more of a play with this, and I've actually got that little 1 transistor preamp that I'd built connected up. I'll show you what we're getting up to now. We've got some more volume and it's quite nice and clear, but we still do have problems with buzz. But that's basically due to the fact that at the moment I'm running the whole thing just off that modern 12 volt switch mode power supply. This is what's creating the buzz that we've got. But I'll just connect this up and show you what it's doing. So we'll switch on. We'll start playing the record. There we go. And connect the power up. We've got a reasonable amount of volume there. It's a little bit thin, but we can work on that later. I've got a few ideas for getting a bit more fidelity out of it. But you can hear that horrible buzz in the background. Now listen to this. Obviously got quite a big smoothing cap in these. But if I unplug it, so we're just running off the power that's stored in that until the power went off. You hear it went quite nice and clear. So basically what we'll just stop this now. Basically what we're going to do today is we're going to actually look at making a power supply to actually drive all this, so we're not using a modern switching power supply like this, because this is what's introducing all the noise and all. I thought it was just general switch mode power supplies I've got set up up here, which like I said, they're a bit inevitable. But it actually turns out no, it's most of the noise that's actually coming from the switching power supply I was actually using to power the amplifier. So we need to do something about that. So what we're going to do is we're going to build our own little DC power supply, which is going to run off that tap on the motor. What I think I'll do, I'm just going to get this all out of the way so we've got a clear bench to work off, and then we'll have a look at actually putting this little circuit together and testing it out. So back in a sec. Okay, now roughly this is what we're going to do. We've got a tap in here on the motor. This is off the so basically this is an auto transformer. So what you've got is imagine this here is the winding for the motor, and you've got 240 volts. Basically you've got neutral there, you've got live there, you've got 240 volts AC there, and that's your induction motor in your record player. So that goes off to your live, that goes off to your neutral. That's what spins the motor. Now this motor basically is being used as an auto transformer, so we've got a tap coming off that part way along. So on a lot of the One Valve Wonder record players, that tap will be at 90 volts and it's used to drive the 2 heater filaments. In this instance, I think it's around about 18 volts. It's around the 18 volt mark, and we've got this tap there. So what we need to do is we need to rectify that, turn that into DC, smooth it, regulate it a little bit, and then we can use that to power both the little preamp circuit and the actual power amplifier. Now I actually want to run them at different voltages as well. Mainly down to the transistor that I've used in the preamp. If I'd used a slightly beefier transistor, I could have probably just run them both on the same voltage. Basically, what we're going to have, so what we're going to need is a bridge rectifier. So what we're going to have 4 diodes. I'm trying to remember how to draw this now, so I don't look a fool. But basically what we're going to have is we're going to have 4 diodes. I'm trying to remember which way round they go. But essentially think, if I'm right, I want that to go, I think it's that way like that. I'm trying to just remember off memory which way around these diodes going. I'm sure I'll have it the wrong way. And we want, in fact, shall I look? Because I've got a circuit here that I drew. In fact, we could just have a look at this one, because this is basically what we're doing anyway. Right, can you see that on screen? Right, there we go. So we've got roughly like 18 volts or so off that tap off the motor. That then goes through a bridge. Yeah, I was drawing it the right way, weren't I? Never mind. Basically, it goes through a small bridge rectifier there. That converts it into the DC. We've got a reasonably large, beefy smoothing cap there. I'm going to use a 47,000 UF. It needs to be probably about, say, 35 volts or something like that. I think the one I'm going to use is a little bit bigger than that, but it's what I've got lying around in stock. And then, and this is a slightly bit unusual, basically that's going to then go off, and that's going to provide us around about the 22 volts or so, which that Velleman amp's quite happy with to drive the power amplifier. What I'm also going to do is I'm going to tap off that with a 7812 voltage regulator, which is basically going to give me a stable 12 volt supply, which is what I'm going to drive the little one transistor preamplifier with. I have put a bit of smoothing in there. That's probably not 100% necessary, but I'll probably leave it in there anyway. So the idea is we're basically going to knock this circuit up, and I'm going to build it in pretty much the same way as I built the little one transistor preamp. So what we're going to use is just a little bit of circuit board like that. Now I've got, it's a nice big, it's a Nichicon as well, nice big beefy 47 UF smoothing cap there. It's overkill for this, but like I say, it's what I've got in stock. It'll do absolutely fine. It's 63 working volts. You could get away with like 35, something like that for this project, but seeing it's as what I've got, it'll do. We've got a 7812 voltage reg. Instead of using 4 diodes to create the little diode bridge, I've actually got I've got quite a few of these kicking about. I found them in a box. It's just a little monolithic voltage rectifier. So it's basically the 4 diodes of a bridge rectifier all in one little package. Looking at it, could even be a selenium one. It's old. It's probably late 60s, early 70s vintage. I've got a few of these, and I've got a few ITT ones I found in a box. It should be absolutely ideal for this project actually. So then, like I said, I've got another, I think it's about 1000 UF or something, which I could use as a bit of smoothing on the end of the 7812. It's probably not necessary in this application, but we might go for it anyway. So what we need to do is get all this built up basically as that circuit there. Should be fairly simple to do. Biggest problem is getting everything really mounted on the board. I'm not a huge fan of this type of prototyping board. I prefer the stuff that you've got copper tracks actually built into the board, and you cut the track where you want it and make your circuit like this. This just has little plated holes, but I've got quite a few of these that someone gave me, so it seems a shame to just have them sat lying about in a drawer, and they should be ideal for things like this. It made that little one transistor preamp quite nicely, so I think this should be okay for making the power supply as well. Right, what we are going to have to do is we're going to have to make a few holes in this a tiny little bit larger. Basically because like this big capacitor here, it won't actually fit very nicely in. Oh, he says it might do actually. Perhaps I'm not going to have to Dremel it out. No, I thought I'd have to. Well, perhaps. yeah, possibly to get these to fit really nicely, we're going to have to do a little bit of. Let's have a look. See, it sits like that, but if you see it, there's a. I don't know if you can make that out on the camera, but there's a gap between the board and the PCB, and I don't really want that, so I am going to basically get my PCB drill and just enlarge them holes where the main smoothing capacitor's going through. So I want that to sit. I want that to sit flush against the board. Get that in there. Why won't that plug go in that hole? Won't get in that hole. And for some reason that plug. Oh, the piston socket's got bent. How's that got bent? Don't think that's too important. We can unplug that and plug it in there. Sorry about this, folks. I need to change all of my sockets now. Right, so hopefully we've got. Yeah, that should work. And what we need to do, we count. We've got, what's that? 1, 2, 3, 4, 5. So we'll spin this over and we'll just drill these holes out. Right, we'll have that pretty central, so let's start that with that hole there. That should do. And then 1, 2, 3, and that hole there. Right, hopefully that big capacitor will now go in. Let's see. Might need a little bit. That side goes down. Let's have a. There we are. That's better. Look. You can see that's now gone right through the PCB, so we can solder that nicely into place. Let's see if we can get the little bridge in there. Oops. Let's see if we can get the little bridge in there as well. And basically, we're going to solder most of these components into place, and then we'll look at actually connecting them up on the back with some wire. Now, I'm just trying to see where the negative on this one is. There's plus there. Oh, negatives there, right. Doesn't make that the easiest of these bridges to connect up. In fact, that wouldn't matter too much, would it? We could just put it. I'm just trying to see on the. Yeah, those are the AC sides, so we'll put it in that way, like that. Where's the negative? Is that the negative? That's positive, so. Well, just spin this. Put it on that side, couldn't we? PCB, component placement can be quite critical. What we'll have to do, let me just spin that over. What I'm trying to do is get the negative of the bridge there as close as we can to the negative pin of the actual. That's it. Of the little bridge. Just make life. Or the positive. I suppose if we got positive to positive, that'd work, wouldn't it? That's it. Right, so we'll have it on in that way around there, like that. It's a bit close. Let's see if we can come out a bit. There we are. Push that through. As you can see, so basically we've got, that's the neg there, that's the positive and positive together, so we're going to have to join those two wires together, That's going to be the input, the AC input on that side there. So we'll start by just soldering that into place, mainly so we don't lose that component off the board. Now I'm quite happy for that to stand off the board the way it is doing. For one thing, I think that allows a little bit of airflow around the component. I mean, the capacitors don't particularly run hot, but these can run a little bit warm. And it does look like it was actually designed, if you look like that, look there, to actually stand off the board. And because it's got 4 legs, it should be quite nice and secure once it's soldered in place. I wonder if we should put... No, we could do that in line. We might put a little inline fuse as well between this and the actual winding on the transformer. But we'll do that as an inline fuse mounted to the board. We don't need to mount it to this. Let's just get this, we'll get this soldered in place. First one. There. I think his legs might be a little on the tarnish side. They are taking a bit to take the solder. They look clean enough when I inspected them, but that's okay. Yeah, they're coming round now. There we go. So that's held in place. Now what we'll do, that big smoothing capacitor, we're going to fold the legs over flat, just to give a bit of mechanical strength as well as anything else. But I don't want to risk cracking the board doing this. I've done that in the past when you've got a big heavy component like this and you're mounting it to a little thin PCB. You can actually crack the board. That should do. And then we're going to have to bridge some wires across to them. So that capacitor is probably a little bit overkill for a board like this, but it will work. It will definitely work. I just bent them over that like that, just so they've got a good physical connection. Then we'll solder them in place, and then we can link it all. Up. So let's solder. So that one's flowed okay. Solder that one in. That's going to be our ground connection there of the main capacitor. Right, there we go. So that's the 2 main components in place. We have our AC input off this side here, and then we need to run a wire between those 2 points. And what I like to use is any bit of solid core will do for this. And we're basically going to farm tracks using the little plated holes on here. What we might do is we might just stick the next component in actually. And we've got a 7812 here. Now I think it's pin 1's voltage into pin 2 is ground, and pin 3 I think is our output voltage. So we want this. That's going to be pin 1. We want pin 1. Let's get that about there, I think. In fact, we'll move that over a little bit. I mean, on a circuit like this, none of this is particularly critical spacing wise. I just want it to not be too crowded, obviously. So we'll have that in there like that. Now, we're only going to be running few milliamps, so I'm not too worried about heat sinks on that. So it's literally just there to give us a very low current, 12 volt. Sorry, you can't see what I'm doing. So I'll zoom that camera out just a tiny little bit so perhaps you can see. There we go, that's probably better. So you can see what we're doing here. Right. So we're going to mount that. Just make sure we've got that the right way around. Yeah, that's pin 1 is there. That's going to that side there, that's fine. That's going to be our output there, so we're going to put this this capacitor on the output. That's going to be about there. And that can go back up to ground like that. And that pin there. Right, so we'll bend that up. We're going to have to be a bit careful. We'll bend that at a very slight angle. Nothing has to be straight on these boards. I just want to keep it a bit farther away from that, which is going to be the input wire. But essentially we want those two to join together and then go up to that ground point there. And then that's going to go across to the ground on there. Let's solder some of these in place just to hold things down for now. Okay. Now, let's see which one that's going to be our 12 volts output. So what I'm going to do, I'm going to bend that through the board. I need my little tweezers now. Where've they gone? Come on, little tweezers, where have you gone? The usual thing, so you get all the tools you think you're going to need all set up ready, and then all of a sudden something you think you're going to, you didn't think you're going to need, you suddenly are. You should do. So pull that wire. Come on. Ah, you bugger. Come on. There we go. Pull that up through there like that. Yeah, it looks okay on that side. We can push that down. Push that flat on that side with these. I'm going to push that back down again. Like that. Get hold of it at this side if I can. I'm going to fold it back on itself like that. If you can see, we've got that little nub that I've left stuck up there now, and that's got what we can actually connect our 12 volts output from. So basically I'm using the leg just to create a little terminal for us to then we can twist the wire around it and solder it, and we've got a really nice terminal. Because obviously, like I said, this is going to be mounted down, and I don't really want wires just stuck to this. I'd rather have it done in a way that I can easily connect and disconnect things, and that makes a bit of a need to look at it. So what we need to do now is just solder that in properly. Basically, that'll be the first one that we've actually done and soldered down. I'm not a big fan of this type of board, but you can do some reasonably neat work with it if you're patient. Something like that. Okay, so that's our output from that. We now want to connect them grounds up. That's our output. And for the grounds we want to connect those two together, and then they need to go to that ground pin there. So bring that over there. Put a fold in that to bring it across to where we've got all the ground there. In fact, I'll just slip it under there. And we'll solder that up. And then we'll take a wire from that point there over to that ground there. Okay. Watch Great Scott, some of his videos. He likes using this type of board. He builds all your really complex circuits using this technique. I've got to hand it to him. It's must be something you need quite a lot of practice of. I can do something that'll do the job and it'll look reasonable, but I can't make it look as neat as he ever does. And he seems to do all his work like this, using this type of board. I'm going to need some wire now to join them other connections up. And I've got some solid core here we can use. It's basically very much like, you know, component wire, so it will do nicely for this. So we need to connect, first we need to connect between there, and from there down to that pin there. So we might as well start. I'm going to tin the wire up, I'm going to lay it on there, and then I'm going to start running it across. Touch it to there, and then bring it across to the live on the, the positive off the rectifier there. Let's put a bit of tinning on this. Just tin the end up. There we go. Let's try and connect that. There we are. Right. Now, a couple of options of ways we can go with this. I think we'll solder it to that pin there first, off the capacitor. We'll lay it down next to it, heat it up, get that to flow into there. Okay, that's okay. That's joined on there. It's only, in fact, I'll perhaps just put a tiny touch more solder on that. It's not quite as much as I wanted. That's better. And then we'll bring that round to go to its actual connection there. Then I think what we'll do is we'll bring it down to where we're actually going to output it from the board. So, yeah, that should be okay actually. We'll cut the excess off. I say excess. Cut the spare off there. We'll get that soldered on there, and then we can work the rest of the wire down. We can use it to bring the output. Just hold that in place while I Let's solder that. I mean, you could make a printed circuit to do this, but there's so few it's like that preamp. There's so few components. I really don't see the point in it. It's easy enough to just make something up like this. And I've seen quite a lot of, you know, commercial products that I've worked on. You know, the small production run stuff that's used in, you know, like audio and AV and stuff, and it's actually had bits of Vera board and you name it in it. We can fold that back on itself possibly. I'm literally just trying to make, like I did there, a little connection that we can solder the wire to later when we're actually using this. And we want to get this wire reasonably flat down. It's a little on the springy side. This, but we should get something that works. That should do. Right, let's try and solder them. We'll solder those into place as well. I mean, these will actually take far more current than they'll ever need to, but might as well have it quite beefy. There we go. That should do us. Right, so that's the higher DC output is basically going to be on that there. Then we've got the 12 volts out there. All we really need to do is connect the rest of the rectifier up and wire all the grounds up, and then we should be okay. We should be good to go with this. Again, we'll just use a little bit more of this this old hookup wire, and we're going to need a wire that goes from there to there, and then one that goes over to the ground point on there. We'll probably run that over the top actually, so we're not risking shorting anything. So what I'll probably do, I'll run a wire in like that, and then we'll bring it through the board. We'll bring it through there like that. We'll go around there like that, so it can be soldered to there. It would be a lot neater if you made a little PCB for this, but I really don't see the need. Let's solder that there. Oops. Okay, I'll hold that down while I get this tightness in place. There we go. There we are. And then that wire there needs to be brought over and connected to those there. Probably a little bit on the long side, so let's trim it off. don't need to go all to the way to the end, provided it just hooks in within grounds. That'll finish that, and then basically we run that ground over to there. We'll bring our 2 AC out there, and that should be the circuit done. It is that simple. So you can easily get away with this type of Vera board for doing this. Plus you burn your bloody finger if you're daft like me. There we go. Definitely not as good as this. Good as at this as Great Scott watching his video. See, he does seems to make all his boards like this in this using this technique. Anyway, I'll give you some close-ups when I've finished, so you can get a better idea of it. Right. Now we need to bring that wire around so we can go in there. I think we can actually go round and under. Yeah, we can go through there, can't we? Yeah. There we go. So we're through there. And then we literally need to just come across and then down, and we're on the right place. Cut that off, strip a bit of this back, there we go. Then we can just fold that, like that, snip the excess off. There's a little bit too much there, and then we need to solder that one, solder that in place. Okay. There we go. So that's soldered in. I'm just going to solder these wires down that I hadn't done before. I'm basically just soldering into the little pads underneath. So like basically I'm farming my own printed circuit board tracks using bits of wire and soldering it to the copper holes underneath. So, like I said, it seems to be exactly as Great Scott, if you watch any of his videos. He seems to do a lot of stuff, you know, Arduino based and automation, all sorts of interesting stuff. It's quite a cool channel to check out. There we go. So basically all we've got to do is put the AC in on this side there, and that should do for our oh, and obviously we need a DC. We need a way to get the DC out as well. It's a stupid sod of me. I should have done this before. I'm going to need a little loop there to connect one side of the AC, another little loop over there to connect that, and then we're going to also need a ground, an output for the ground connection. Okay, so we'll use a bit more of this solid core wire to do all that with. Let's try this. We'll try forming a little loop. And we'll try pushing that through. From this side like that. Should probably left myself a little bit more room here, but there should be enough. Okay. this is exactly how I've made the terminals that I've used on the little one transistor preamp as well. Solder that in place. Solder it there. Okay. We need to make another one. We might make it a little bit further over so there's a bit of space between them. We need to make another one of them for the other AC input, and then like I said, we need to make something for the ground connection, and that's basically this little power supply PCB built. I'll try going up and then we can test it. Push that through there, bend that over, and bring that over there like that. Solder that in place. Okay, we need to solder that to that connection there on the little bridge. Okay. Get rid of the rest of that excess wire. We don't want that shorting on anything. Like that. There's a little excess bit there, we need to just snip that off as well. These are not the best snips to be using. Right, and like we did last time, we'll just strengthen up that connection. There we go. Lovely. And last but no means least, we just need those two connections for the grounds to come off the negative there. So what we'll do, push this bit of wire through there. That can be bent over and connected onto the negative, the negative of that capacitor, the main smoother. Ooh. Push that through, that's one. And bring it back. Both wires could share that same connection, but I think I'm going to put two on, so they can have one each. That on there. Pull that through again. Fold all that back on itself. There we go. And all I have to do is solder that into place. There we go. Now if we solder all that down, that should give us our nice connections. First one held in. I just really not really use this technique very often. I can see its merits. I think of it as anything. I just prefer my I prefer the strip board with the copper strips already made into it. I suppose if you're doing something like a power supply like this, I suppose this does have its merits. we go. Yeah, that doesn't look too bad. Hopefully we can get that solder blob off there. Don't think it, yeah, there we go. I didn't think it had really stuck. So there we go. We'll get you zoomed in so you can have a little bit of a closer look at it. So basically that's the power supply. So we've got two little loops here which we can solder. Sorry, you can't see because of my big fat fingers. Let's take a pencil. If you look here, we've got them two contacts there and there. Those are for our AC input off the motor. We've then got two ground connections there. We've then got a 12 volt output there, which is basically going to drive the preamp. And then we've got probably on load around about 20-22 volt output there, which is going to be what actually drives the power amplifier. So basically, I think the next thing we should do is I'll go and get the rest of the record player, get it all set back up, and we'll give this a test and see how good or how bad the distortion on the audio is with using this rather than using that switch mode power supply that it was testing with. So back in a sec. Okay, we're back. I've got everything set back up. The only thing I've done is before, like I said, I had the preamp and the power amp connected to just run off the same 12 volt input. I've separated them, so I've got those two wires connected up to the power amp, and I've got obviously those two wires to the preamp, because obviously we're going to different places on the new power supply we've just knocked up. These are the AC wires off the motor. This should give us a low voltage AC, but before we go any further, really, we want to check that. We just want to make sure that we've got a reasonable low AC voltage coming off these. So I've got my meter. It's not my usual meter. I think I might have left it at my friend's house, unfortunately. But it's a working meter. It can give us a good idea. So I've got that set to AC voltage, and I'm going to connect it to the two white wires off the motor. Then I'm going to switch on, and we'll just see what volts we've got coming off this. So switch on there, and yeah, 17.5 volts. I was rating it on the props about 18 volts, so that's not bad there. So we know we've got 17.5 volts AC. Coming off the motor, that's good. So before we connect it up to the rest of the circuit, let's connect the power supply up, and then we can actually just make sure we've got some sensible voltages coming out of the power supply. We will be putting a fuse in line if we actually decide this is the way we're going to go. We will be putting a fuse in line here, but just for testing, I'm not too worried. Let's get this soldered to the circuit, and then we can test that the circuit is working okay. Tin up these two connectors that I made like that. That will do. I'm just double checking that I have wired this up the right way around, because I hate it to go pop. Yes, it does look alright, that. So we'll solder the output from the motor to the power supply. Well, we're just going to tack it on for now, so this is just a lash up. This is literally just a lash up for us testing. Is that taken? Yep, that'll do. This will be a lot better when we have it all mounted properly, but like I said, for the time being, you want it so I can easily disconnect these wires again and fiddle about with it. We are just prototyping at the moment. So if you're doing a repair, you'd never want to just lay wires on like that and just solder them really. You want to make a good mechanical connection first, but we're not about that at the moment. We're about just seeing if we can get things to work. We can go and do it all neatly after. Right, so that should be the power supply energized. So let's see what we've got on our outputs. Obviously the output that's going to be going to the power amplifier, that's probably going to float a little bit on the high side because it'll have no load on it. The 12 volt output for the preamp should be bang on 12 volts for the simple fact that we've used that 7812 voltage reg there. I think we'll test that first. So I've set my meter to DC at 20 volts. We'll connect that onto one of the ground connections there. We'll connect that onto the output from the 7812. We'll switch on and we'll see what voltage we get. Hopefully we should get right about 12 volts. It should be pretty much bang on 12 volts actually that we get out from there. Just double check that I've connected everything the right way around again. I don't want a capacitor to emit the magic smoke. Note that all looks good. Centre pin is ground on that. I do hope I've got that right. If not, it's going to eject a 7812 at me at very high speed. Now let's switch on and see what happens. And there we go, we've got 11.89, so that's close enough to 12 volts for me to be happy with. So we've got our 12 volt output from there. Let's see what the higher voltage output is. No, switch on. It's higher than 20 volts. Remember, this is offload. Ooh, 22.20. Yeah, that's. I'm pretty pleased with that because that'll come down on load. We've got about 23.5 volts there, which is what's going to power the little Vellum and kit amplifier. I think they're good up to about. I think some people have said 28 volts. Other things I've said have said 24 volts. So it should be okay. Let's get this all connected up and see if we've made any difference to the actual record player. See if we've got rid of some of that horrible buzz. Right. Some solder. So there's plenty of component values we can play with yet to actually get the sound quality we want out of it. We might even think about possibly even a different preamp. If this preamp doesn't work out, there's various IC based preamps we can look at using. I just like the idea of just a simple one transistor. I have done similar things before with these little cartridges and got it to work. Right, there we go, we've got some tin connections on there. Let's connect the preamp up first. Put him back there. And there's going to be plenty of space actually in the record player to fit all this in, so that's not a worry. Get you off and we'll get you soldered on there. Okay. And that goes. Oh, let's get the other ground while we're doing grounds. Solder you on there. That'll do. Now let's get the two main connections connected. So that's the 12 volts for the preamp. I mean, this could just squeal horribly and we'll have to go back to square one, but we shall see. So this is all just me playing about with some old junk that would otherwise probably ended up eventually in the tip. I don't think I'd have ever rebuilt it with a valve amp in it. It probably just ended up, you know, catches and handles and things being used on other record players. So if we can save it like this, it's cool. Right there, that's everything connected up. So we've got the preamp, the little power amp for the power supply, and that's being driven off the motor in the record player. Let's turn the volume down, and shall we switch it on and see what happens? Let's give it a go. But we have still got some buzz there, obviously. But let's see if it plays any better. A lot of this could be down to the proximity of where I've got things. In fact, we've not got anything screened at all. But let's have a see if it plays any better. I might get rid of that tone. Just temporary. I might just get rid of that tone network and just feed straight into the volume control. Let's try that. It's not lying there. Which way am I going into? I want to go into the centre of the volume control. Oops. No, I don't. Still got that horrible buzz we need to get rid of. We need to find out where we're actually getting that buzz from. Whether we're just picking something up. See, everything... It could just be the fact we've got all the boys just lying about and we've got a lot of crosstalk and interference, to be fair. You can see everything I touch is a bit... That's it, me even touching the input to the power supply. That's me touching the 22 volts going into the Bellman. Let's try playing it again. We're getting there. Definitely getting there. think basically the power supply I'm reasonably pleased with. Obviously the amplifier, yeah, I'm quite happy with that, but I'm not happy with the preamp circuit. I don't think it's driving the rest of the circuit very well. It's about the simple and the crudest little preamp you could come up with. So it's just one general purpose MPN transistor, taking the output from the cartridge, giving it a little bit of a boost and going straight into that little Velleman amp. I don't think it's got quite the boost that we need. I might look at a little op-amp, using a little op-amp based preamp, see if we can get a little bit more out of it doing it that way. I'm going to leave it here for now. Like I said, you've seen the power supply. I'm quite pleased with the power supply. The power supply is doing exactly what I want it to do. But it's clear enough. But I think a lot of our issue now is going to be down to that. I'm just not 100% happy with that preamp. Let's just disconnect. Yeah. Now that's the preamp disconnected. That's the literally just the amplifier being driven. In fact, if you ground that out, that's pretty well silenced. Oh, well, I don't want to damage my record. So my little preamp that I knocked up, like I said, it's the simplest preamp circuit you could get away with. I don't think it's going to work in this instance. I'm going to look at perhaps using a little op-amp to do the same thing. So in the next instalment of this, we're going to be working probably on this preamp, see if we can come up with something better that's going to take the that tiny little output from that cartridge and get us something which is going to drive that little amplifier a little bit better. Anyway, I'm going to leave it there for now. I hope you enjoyed this little update on the project. So thanks for watching and goodbye.